Good afternoon, everyone. I'm delighted to see so many people on a Friday afternoon. This really makes my heart leap to know that you haven't yet left for the slopes. So welcome, everyone, to this event in the second season of the Provost Forum on the Public University and the Social Good. We're very happy that we're having our second season. I feel like it's a program that's been continued on the networks, building on our successes of last year. This afternoon, we're very, very privileged to have as our speaker Professor Naomi Oreskes of Harvard University. All major research universities devote a great deal of time and effort to attempting to solve our most pressing and challenging global problems. I'm speaking especially of problems in such areas as human health, the environment, and energy that bear directly on the quality of all of our lives. There can be no question that we tackle these problems in large part because we recognize a fundamental responsibility to use our unique resources at universities for ambitious goals that serve more than their own immediate interests. In other words, we seek to improve society and individual lives. American public universities, such as the universities that belong to the University of California, are no exception. A public service function, originally conceived for the benefit of individual states, but now transcending all borders, is a formal part of our mission. This enduring sense of an extensive or inclusive responsibility is something that should give us all a cause for optimism about the fate of universities, of public universities, and of the world. At the same time, we cannot afford to be complacent about the strength or health of this attitude given the socioeconomic environment that in many ways is threatening its flourishing. If we value universities' sense of global responsibility, we must commit to regularly taking its temperature and administering the proper medicine when necessary. It's difficult to imagine a topic more vital to the health and welfare of the world's people than the one Professor Oreskes will address today, global climate change. For this reason alone, we can say that her lecture will supply an essential, valuable perspective on what universities do and should do. I won't wade too deeply into that pond because Professor Schwartz will take the podium soon and give a proper introduction for our speaker and her presentation. But I do want to make one observation. The work of Professor Oreskes highlights two distinct roles, I think she would say responsibilities, that universities have with respect to global challenges such as climate change. The first role is to create the advanced knowledge necessary for the development of accurate understanding and sound policy. This knowledge clearly will be most valuable if it draws on the resources of both the STEM fields and the human-centered disciplines. The second role of universities in such a case is to participate in the larger public dialogue in such a way that they make their advanced knowledge widely heard and its true import recognized. Professor Oreskes has done this with great effectiveness in her 2004 essay, The Scientific Consensus on Climate Change, and I expect she will further that effort in this forum. Before I leave the subject of today's program, let me remind you all that you are invited to continue the dialogue on climate change in the public university during the reception in this room immediately following the lecture. Now, a quick look ahead. Today's lecture will be followed by 5 more during this academic year. In the coming months, distinguished guest speakers will address a variety of subjects related to public higher education from a variety of perspectives. Among those subjects, the value and role of the humanities, the public university's contributions to regional development, and campus diversity. Our next forum on Friday, March 14th, will feature Professor Robert Post, Dean of the Yale Law School, who will speak on academic freedom and participate in a panel on that issue organized by the Academic Senate's Committee on Academic Freedom and Responsibility. This event will be held, as I said, on March 14th from 2 to 4 p.m. in the Studio Theater of the Mondavi Center, and a reception will follow immediately in the Yocha Dahi lobby. I hope that all of you will be able to attend many, if not all, of this year's remaining lectures. If you miss one, videos of all events along with other materials will be easily accessible on my website. So before I turn the podium over to Professor Schwartz, let me thank personally the Provost Forum's organizing committee for doing such an excellent job planning and arranging our events both this year and last. and 11 UC Davis units that have joined my office to co-sponsor this particular event: the John Muir Institute of the Environment, the Center for Science and Technology Studies, the Coastal Marine Sciences Institute, the CWAS IGERT, the REACH IGERT, the Southwest Climate Science Center, the UC Davis Energy Efficiency Center, the California Environmental Law and Policy Center, the Community and Regional Development Program, the Center for Poverty Research, and the Center for Regional Change. So Professor Mark Schwartz of the Department of Environmental Science and Policy will moderate today's event, and I want to finally thank again Professor Oreskes for speaking with us today. Professor Schwartz.
Well, thank you all for coming, and special thanks to Provost Hexter. I think that these are really important forum to sit through in this era where we're really seeing a rapid evolution of the university and also a rapid evolution of the role of science within the university. And so it's important to come and talk about these issues. So it's my honor to introduce our speaker, Dr. Oreskes, today. She gained her bachelor's degree from Imperial College in London, and then went on to do a PhD at Stanford in both geology and the history of science. And that this is integral into understanding her work, that she really began as a geologist, and many of her early publications are focused on quantitative models and plate tectonics. With that, she gained some notoriety, and she was an NSF young investigator and went from Dartmouth to New York University, was a consultant with the EPA for a period of time. But by the late 1990s, a lot of her writing had drifted or shifted from it's Friday afternoon after all. Had shifted from tectonics to be dominated by scientific laws and the role of models in science and issues of gender in science. And by 1998, she was at the Scripps Oceanographic Institute, where she was working on the history of science, but also science and public policy. And so her work has moved increasingly to write on this interplay between politics, society, and science. And with a particular emphasis on how science is communicated and how we as scientists communicate that science. For the past 10 years, much but not all of this work has been focused on climate change as a particular issue, and has us thinking about, again, science, politics, and society. And this has been well captured in her very popular book, Merchants of Doubt. And if you haven't read this, I highly recommend that you do so. It will change your life. And in 2013, just last year, Dr. Oreskes moved to Harvard, and also she did something else that I think is really notable and worth paying attention to. She wrote an article called The Collapse of Western Civilization, A View from the Future. And this is a really novel approach of working as both a scientist and a science fiction writer. So she's imagining herself in the future, looking back at the history of this climate change issue that we've dealt with and what we haven't yet dealt with and how that might play out in the future. It's a very interesting perspective on it. So hence it couldn't be more fitting for us than to invite Dr. Oreskes here to the Provost Lecture Series on the university and public goods to talk about this issue that faces all of us today. Thank you, Dr. Oreskes.
Well, thanks very much for those kind introductions, and especially thank you to all the different groups on campus who have helped to make this visit possible. It really is an honor to be here. It's also fun. I don't know if Mark stressed, I only went to Harvard 6 months ago. I do consider myself a Californian, and it's always good to be back in California. And so I've been at Harvard long enough that I've drunk enough Harvard Kool-Aid that I do believe that I am now at the greatest university in the universe. But still, California's California. So. With that, let me get started. So Mark's invitation to speak today was specifically on the theme of the university and the public good, and the question of what we as a community of scholars should be doing on climate change. And that's a really nice opportunity for me because I've spent the last 3 years talking to a lot of different groups of people about climate change. And rarely, though, do I get an invitation to kind of turn the focus back inwards towards us to think about what is our responsibility as a community of scholars, intellectuals, researchers, university administrators, what should we be doing? And the word should is always a delicate one because you don't want to be in the position of scolding people and telling them what to do. People don't like that. But if you get invited to do it, then that's kind of a different matter. So I'm a historian of science, and so I want to start today by talking about one of the people who many of us think of being one of the founders of science as we know it, and that's Sir Francis Bacon. Bacon is famous for many reasons, but perhaps most of all because he was the person who coined the aphorism, knowledge is power. And Bacon believed passionately, and he wrote in his many works, about the capacity of science and understanding, scientific understanding of the natural world, to enable us to do things to improve the human condition. So science for Bacon was all about using knowledge in a powerful way for good. Now, I would argue that that ideal, that Baconian ideal, sits at the root of pretty much all scientific research that's been done since the scientific revolution, and clearly at the root of the modern research university. And it continues to inform us to the present day. It underpins the justification for spending taxpayer money to support what we do as scholars and not just teachers. And when I was teaching for 15 years in the UC system, I often felt, I have to say, that my own administrators didn't do a good enough job of really explaining to the people of California why we should be spending taxpayer money doing the things that we do. That and the fact that all my neighbors thought I was just a teacher and thought I had the summer off. But one of the interesting challenges that we face today is the reality that in the case of climate change, one of the great issues of our day, knowledge has not translated into power. Sorry, I can't really read my notes here because somehow I have a little, very tiny screen here, and I don't know how to make it bigger. I can't do that. But maybe I can. Oh, now I've lost it completely. Uh-oh. That's not good. Technical difficulties. Oh, there we are. OK. So now I've lost track of where I was. OK, here we go. That's it. OK, so you know what I might do? I don't like being behind the podium anyway. If I come over here, I can see my slides. Can you hear me if I do this, though? OK, this is better anyway. I like this better. It's more fun and yeah. OK, so in the case of climate change, one of the things we know is that scientists who have been working on this problem have a very robust understanding of climate change, an understanding that's both robust and intricate. And this is knowledge whose roots, whose pedigree, are as good as really any of the things that we would say we know scientifically, a pedigree that goes back more than a century. And yet we also know that our society has not acted upon this knowledge. OK, but the question is, oh, this, you know what? Sorry, I have to do this, right? Sorry, time out. OK. What, now I'm losing the lights. What's that about? OK. All right. No, that's bad. Don't go to sleep. What's that? I have 30 seconds. We're out of time. The world is coming to an end. OK. There we go. OK. So what I want to do today is three things. Firstly, I want to spend a few minutes recapping the history of that knowledge to underscore the point that it is knowledge. It's not just a claim or a fad, or as many of us know, it's not just a theory. And then I want to speak a little bit about the research that my colleague Eric Conway and I did in writing the book Merchants of Doubt, to talk a little bit about what we've learned through our research about why that knowledge has been challenged, doubted, belittled, and not acted upon. And then present a few ideas about our present situation and what we as scholars might do in response. Now, disclaimer, I'm not going to talk about what the university as an institution should do, such as putting solar panels on the roof. I'm going to take it for granted that the university should do that, if you haven't already. But so should all institutions, businesses, homeowners, landlords. I'm doing that myself at home right now. But what I want to talk about specifically is what we as scholars and intellectuals and researchers should do. That is to say, the specific role of the university, the things that are unique to our mission, versus other institutions who could also install solar panels. OK, so let's start with a very brief history of climate science. A good place to start understanding the history of climate science is with the work of John Tyndall, who was the person who first established the concept of a greenhouse gas. through a series of experiments that he did in the mid-19th century, so more than 150 years ago, he demonstrated that water vapor and carbon dioxide had the distinctive properties of being essentially transparent to visible light, but almost entirely opaque to infrared. And so that light from the sun could reach the Earth, but would be trapped by carbon dioxide and water vapor in the atmosphere. And this was basically a good thing, because otherwise the planet would be too cold to be inhabitable. Now, in the early 20th century, Svante Arrhenius, the Swedish geochemist, recognized that burning fossil fuels put carbon dioxide into the atmosphere, and that therefore burning fossil fuels, at that time mostly coal, had the potential to change the radiative balance of the atmosphere and cause the Earth to warm up. Arrhenius did the first calculations of what the effect of doubling CO2 would be, and he calculated that it would be between 1.5 and 4.5 degrees centigrade. And one of the interesting facts about that history is that this calculation has scarcely changed in 100 years, right? We've done a huge amount of additional work, but basically that answer has held up over time. Now, Arrhenius was Swedish, so he thought global warming would be a good thing. The first person to say that it might be a bad thing, and also to say that it might actually already be happening, was the British steam engineer Guy Stewart Callendar. And if you haven't read it, Jim Fleming's written a wonderful and interesting biography of Callendar. But he wasn't the only person. Actually, in the 1930s, a discussion began to develop, and people began to publish papers about what was known at that time as the Callendar effect, the idea that increased carbon dioxide in the atmosphere could warm the Earth. So this is an early paper published in Physical Review. Whenever I meet a physicist who's skeptical about climate change, I say, look, the basic principles were worked out in Physical Review in the 1930s. Like, what's not to like? And then the issue was taken up again after World War II. Like a lot of things, the issue of the Callendar effect got sort of put aside during World War II. But it was taken up again after the war here in California by people I think of as our own colleagues in the UC system, Roger Revelle and Hans Suess, both professors at the Scripps Institution of Oceanography. In 1957, they published a now famous paper, although mostly ignored at that time, in which they pointed out that by burning fossil fuels, humans were putting back into the atmosphere carbon that had been stored in rocks, in coal and oil and gas for tens or hundreds of millions of years. And that this was really a very significant and profound thing. And they wrote, human beings are now carrying out a large-scale geophysical experiment. Within a few centuries, we are returning to the atmosphere and the oceans the concentrated organic carbon stored in sedimentary rocks over hundreds of millions of years. And actually, they could have even said within a few decades, because the vast bulk, more than half of all the CO2 in the atmosphere today, has been put there just in the last 50 years. So it's actually really decades. And then they say, and this is kind of interesting, because here's how you know they're really scientists. This experiment, if adequately documented, may yield a far-reaching insight into the processes determining weather and climate. So they see this as a kind of natural, or not exactly natural, unnatural, natural experiment in which we could actually use the fact of increased carbon dioxide to better understand the role of greenhouse gases in the atmosphere. And so Revelle becomes an advocate for the idea of paying attention to what is happening. And he negotiates and lobbies for funding under the International Geophysical Year for this man, Dave Keeling, to begin the systematic measurement of carbon dioxide in the atmosphere that we know today as the Keeling curve. I was at the National Academy of Sciences recently, and on the walls of the National Academy of Science, the Keeling curve is now engraved next to Darwin's finches. So, like, it doesn't get a lot better than that, you know, right? I mean, this is science at the highest possible levels. And that work is more than 50 years old. In fact, I can just say, it's very easy for me to remember when the Keeling curve begins, because I was born in the same year as the Keeling curve. It makes me feel a little old, but the Keeling curve is 55 years old. So this is a short, brief history of time. Sorry, no, a brief history of carbon dioxide. So lots of things to skip. If you're interested, my forthcoming book in the history of oceanography goes into a lot more detail about Revelle and Suess and how oceanographers got interested in climate change. But by 1979, this work was broadly accepted within the community of people who were studying climate in the atmospheres and oceans. And as just one example of that, 1979, the US National Academy of Sciences said in a press release that went with a report that they were issuing at that time, a plethora of studies from diverse sources indicates a consensus that climate changes will result from man's combustion of fossil fuels and changes in land use. This is such an interesting press release because of a number of things. First of all, you'll see that they use the word consensus, So it's what we historians call an actor's category. I've been criticized by contrarians who say, oh, science isn't about consensus. It's about the heroic individual who goes against the consensus. No, actually, that's not right. It is about consensus. It's about what experts studying a problem believe to be the logical conclusion from the data and evidence that they've accumulated. Some contrarians also have criticized the scientific community for ignoring land use changes, but that's not really true either. Actually, we see that very early on, scientists understood it wasn't just about burning fossil fuels. It was also about deforestation, agricultural practices, and other land use issues. Again, fast forwarding again, now we'll jump to 1988. By 1988, Jim Hansen and his team at NASA were willing to state in public that they were 99% certain that anthropogenic climate change had become detectable. So just to go back for a second, if you look at this, what you see here is this is really a prediction. This is a prediction about what you would expect based on what you understood about how carbon dioxide was rising and its impact on the climate. So this is a prediction about an expectation, and by 1988, that prediction is coming true. 1988 is also the year in which the IPCC was created with the express purpose of communicating scientific knowledge to the organizations of power, that is to say, governments. The whole model of the IPCC is a model of knowledge being power. Scientists will figure out what we know, they will explain it to the governments of the world, and the I in IPCC is intergovernmental, right? This was always meant from the beginning to be about something that governments would use. So that's 1988 that happens. By the early 1990s, it appeared as if the world was ready to act upon the scientific information about climate change. It looked like knowledge was informing power, and that power, governments, would implement solutions based on that scientific knowledge. And I say that because 1992 is the year in which we get the United Nations Convention, Framework Convention on Climate Change. And for those of you who don't know, a framework convention has the status of international law. So this is meant to be a form of international governance to act upon scientific knowledge. And as many of you do know, the Framework Convention commits its signatories to preventing, quote, dangerous anthropogenic interference, sometimes referred to affectionately as DAI, not DOI or DWI, in the climate system. And if you read the Framework Convention, Article 2 makes it explicitly clear that it's science, that is to say, the work and conclusions of scientists that would define what DAI was. That is to say, it would be scientists who would tell the world, well, what level of greenhouse gases represented dangerous interference. So you see science actually written into the international law. Then it goes downhill from there. No, not quite. One more piece of good news before it goes downhill. So in 1992, President George H.W. Bush signed the Framework Convention. So the United States, contrary to popular opinion, is a signatory to the international law on climate change. And when he signed it, he said in his statement that he was committed to translating the written words into concrete action to protect the planet. But that didn't happen. As we all know, more than 20 years later, our world has warmed dramatically, and dangerous anthropogenic interference is underway. Or as some of my colleagues at Scripps used to like to say, it's in our rearview mirror. And not only is it happening, but it's happening in a manner consistent with scientific predictions. So this is just a map put out by Goddard Institute for Space Studies that shows the distribution of warming on the planet. And I put this just to show that it's not just that the planet is warming, but that the planet is warming in a way that scientists actually predicted. So if you read the work from the 1970s, one of the predictions of the 1970s is the phenomenon known as polar amplification. That is to say that the poles, particularly the North Pole, would warm more rapidly than the mid-latitudes because of the effect of snow and ice reflecting the sun. And here we have it, we see it, here is polar amplification. The globe as a whole, when this chart, this was done in 2005, so it's hotter even now. But the mean temperature increase at that time was 0.5 degree centigrade, but you can see that in the North Polar regions, it's as high as 2 degrees, so more than 4 times the global mean. And so this is a nice example of an accurate prediction from climate models coming true. So if anyone ever says to you, models can't be tested, well, that's not entirely true. It is tricky testing models, especially that make very long-range predictions. But here's a specific test of a prediction made in 1979 that came true. That was for the philosophers of science. So, and with this warming, we're increasingly seeing adverse consequences, consequences that are becoming increasingly clear and present. And you all know about the discussions about hurricane intensity, floods, sea level rise, and this is the one I hate the most, that poison ivy is becoming more poisonous. When I go to different places, I like to put in different examples that are relevant to the place I went. So when I moved to New England, I had to add this one to it. Pretty soon they're going to tell us that chocolate doesn't taste as good, and then we'll know the end of the world is coming. Okay, so why? Why didn't the world act on this knowledge? Why did the knowledge that had been accumulating for nearly a century not lead to action? I should say not. Why didn't the knowledge, right? And as a historian of science, one of the reasons I became interested in this was because as I dug into the science, one of the things I felt was wildly impressed by how good this science was, how old it was, how robust it was, the pedigree, the stature of the people who had worked on it. I mean, sometimes it's kind of a cliche of history of science that actually almost any topic, if you dig hard enough, you can find somebody somewhere in Leipzig or whatever, you know, who did this in 1833, right? But that's not that interesting from a cultural standpoint, because if some isolated person that no one's ever heard of did some work that he or she, in those days almost always he, you know, should have gotten credit for, it's sad for that person, but it's not that meaningful from the point of view of sort of the historical development of scientific knowledge. But when really prominent people like Roger Revelle, you know, work on something, or when the National Academy of Sciences is speaking to an issue, then it becomes a more interesting question of, well, why it doesn't gain social or political or cultural traction. And so partly I got interested in this because as a historian, I saw a story of very, very robust science informing policy, leading to policy on the highest possible level, an international treaty, and then it all gets derailed. So when does it get derailed and why? And there's a lot of different ways that this story could be told, and a lot of different places you could start. But of all the diagrams and figures and charts, and this is the other thing, as a historian who speaks a lot to scientists, I always feel like I need a chart to explain what's going on, you know? And of course, historians don't really truck very much in charts and graphs and tables. But then I found this, and I thought, oh, this is good. So this is a graph that shows the changes in the voting patterns of Democrats and Republicans in the US Congress, put together by the League of Conservation Voting, what they call their environmental voting score. So a high environmental voting score is good from the point of view of people who care about the environment, and a low environmental score is bad. And look at this graph. Here are the Democrats, here are the Republicans. And in this period from 1970 to 1989, there's a difference. Democrats are a bit more interested in the environment, Republicans are, but it's not a huge difference, right? And you can see that there are places where the gap between them is not that great. So, you know, it's not quite a consensus, but they're coming to agreement on a lot of issues. And actually, if you go back further, it's closer together. If you go back to the early 1970s, the Wilderness Act passes the Senate by a vote of 73-1. And I did some research into this. One time I was giving this talk, I said, I don't know who the one person was. And the great thing about talking in public is then somebody later on emails you and answers. So the one person actually voted against the Wilderness Act because he didn't think it went far enough. So there was really a very strong bipartisan consensus on at least wilderness protection and some aspects of environmentalism even before this. But then it starts to change, and it starts to change right around 1990. And then you see this very rapid, large divergence till you get to this point. Well, look at 2010. The environmental conservation voters, only a 5% scorecard for Republicans in the Senate, and a 90% or 85% for the Republicans. Is that 80? Yeah, 85% for Democrats in the Senate, and even Democrats in the House, you know, 90% Democrats in the Republicans in the Senate, 12%, right? So this huge divergence, right? So what is going on? Why are the Republicans and Democrats diverging? And why just here? Like, what is it that's happening here that explains why this happens at that moment? And remember, UN Framework Convention is right in here, right? Okay, so. Well, one of the things we know from our research is that 1989-90, around that time, coincides with the emergence of a political movement to challenge the scientific evidence, not just about climate change, but related to a whole host of environmental and public health concerns. And it's a political movement that, like all good political movements, has an ideological core. It's linked to an economic and political model that had actually been around for a long time, but it gained traction at this moment with the collapse of the Soviet Union and the end of the Cold War. And that is the story that Eric Conway and I tried to tell in Merchants of Doubt. It's a story about an organized, systematic, and very skillful challenge to scientific evidence, beginning with the tobacco industry and running through nuclear winter, acid rain, the ozone hole, and then ultimately climate change, also pesticides. Not because the scientific data were weak or inadequate or conflicting or uncertain or because the error bars weren't small enough, but because the implications of these scientific data conflicted with the protagonist's worldview. It's what we've come to call implicatory denial, denying the evidence because you don't like its implications. And it's based, and that worldview is a commitment forged in the Cold War to laissez-faire capitalism as a bulwark against threats to personal freedom and individual liberty. So how do we know this? Oops, sorry. Well, with respect to the climate change, climate science, we can say that our story begins with Tyndall. But with respect to climate change denial, the story begins with a think tank in Washington, D.C. called the George C. Marshall Institute, which was the first place where we begin to see organized resistance, organized criticism, organized skepticism about climate science. For more than 20 years and continuing today, the Marshall Institute has disputed, challenged, and belittled the scientific evidence of climate change and its significance. So these are just two examples that I pull off the web at different times, but this is a typical one. Patrick Michaels, a well-known climate change contrarian, denier, skeptic, whatever you want to call him. The science of warming is far from settled, claiming that we don't really know, that the science is very uncertain, that if we try to do something about it, the entire capitalist economy will collapse. A whole set of different kinds of claims challenging climate science on a variety of different grounds, some epistemological, some political. So where did the Marshall Institute come from? The Marshall Institute was founded by three men, all distinguished, prominent physicists, all who had built their careers and their successes in the Cold War, working on American Cold War weapons and rocketry projects. Bill Nierenberg, a nuclear physicist and the longtime director of the Scripps Institution of Oceanography, who I knew quite well when I was there. Frederick Seitz, a famous solid-state physicist, wrote one of the leading textbooks in solid-state physics in the 1950s, president of the US National Academy of Sciences in the 1960s, and later president of the Rockefeller University. So this is a man working on the very highest levels of American science. And Robert Jastrow, an astrophysicist and head for many years of the Goddard Institute of Space Studies, who was actually my colleague when I taught in the Department of Earth Sciences at Dartmouth. So when I first sort of came across this story and started reading this material, and then I saw that these three men had created the Marshall Institute, and I thought, wow, I knew two of them. and I thought, I guess I kind of have to write this book. You know, there was a weird personal connection that I had to these people. And at one point, I got criticized by the Marshall Institute because I didn't interview these men. Well, two of the three were already dead by the time we wrote the book. But I was like, I don't have to interview them. I knew them. You know? So, yeah, so I knew Bill Nierenberg pretty well. I knew Bob Jastrow somewhat. I didn't ever have the honor of meeting Frederick Seitz. So why did they create the Marshall Institute? These men created the Marshall Institute in 1984, kind of poetic telling year, not originally to have anything to do with climate change. It was about the Cold War, and it was specifically about the question of the Strategic Defense Initiative, or what some of us know of as Star Wars. Ronald Reagan had proposed to build a missile defense shield as part of Cold War defense, and this idea had come under very systematic and sustained attack by American physicists led by Hans Bethe, and Carl Sagan. And they had argued against it on a variety of grounds, both scientific and political. They had argued that it was technically dubious, it would cost a huge amount of money and would probably not work, that it was but more important, that it was diplomatically destabilizing because it undermined the principle of mutual assured destruction that had maintained the Cold War peace. In other words, the whole idea of mutual assured destruction was that neither side would be so foolish as to launch a first strike. Soviets launch a first strike, we immediately launch our missiles, 18 minutes later, we're all dead. So that idea, that balance of terror, was believed to be the key thing maintaining the peace. And it was a very important argument to physicists who worked on weapons projects. And if you've read Hugh Gusterson's book about Lawrence Livermore National Laboratory, he talks a lot about this, because it was how physicists understood what they were doing as a good thing, that they weren't building weapons of mass destruction, they were maintaining the peace and preventing nuclear annihilation. So when Ronald Reagan makes a proposal that seems to destabilize this, physicists got very upset. And so much of the opposition to STI didn't come from grassroots peace activists, although there was that as well, but it came from inside the physics community. And that made Bob Jastrow and Bill Nierenberg and Frederick Seitz really mad because they felt that their colleagues were betraying the United States, betraying the American commitment to the defense against the Soviet Union. And so they organized, oh, and I should just add this, so Sagan and Bethe organized a boycott of program research funds, and by May 1986, over 6,500 American physicists and computer scientists had signed a pledge not to participate in STI research. This was absolutely unprecedented in the Cold War. There had never been a weapons program that scientists had systematically said, we don't want to participate in this. So in response, Bob Jastrow contacted Fred Seitz and Bill Nierenberg and said, help me. I want to set up an institute to fight back against this and to show that the American physics community is not united in its opposition to STI, but that in fact there's a debate. And the strategy they would do would be to counter the attention that Sagan and Bethe were receiving in the popular press by writing letters to the editor, op-ed pieces, et cetera, for sympathetic, hawkish journals like the Wall Street Journal and Commentary. So this was a letter we found in the archives early from Bob Jastrow to Bill Nierenberg explaining what the plan was. And this was, sometimes when you're in the archives, you're going through all this stuff and most of it's dry as dust and you're falling asleep, you're trying to stay awake and you can't drink coffee in the archive, But then you come across something and you wake up, and so having taught at Dartmouth, I saw that and it was boom, I could be half asleep and I would recognize that. I don't know if you can see it, but this is Dartmouth's shield. And these are Indians coming out of the wilderness and being enlightened by the light of learning. It's so great. You can learn so much from iconography. OK. Now here's an important point. The plan was never to debate SDI with fellow scientists in the halls of science. The plan was to create a debate in the mass media. And if the media did not give them equal time, they would threaten to sue under the fairness doctrine. And they would demand equal time, and they would insist that journalists teach the controversy, cover the controversy, right? Oops. Now, their early work was all related to the Cold War in areas in which they had expertise, like strategic defense, nuclear winter. They did some work on seismic verification of nuclear tests, satellite surveillance, and the future of the space program. But in 1989, the Cold War ended. Now, you might have thought that they would have popped open the champagne bottles, right? We won the Cold War, and it was partly through science and technology. But that's not what happened. They took up a new issue. And when I think about this moment, I feel like they're like generals who can't stop fighting. The war is over, but they don't get it, so they need a new enemy. And they find that new issue and that new enemy in climate change. So that very year, 1989, the same year that the Berlin Wall comes down, they published their first report on global warming, what they called, What Does the Science Tell Us? And in this report, which is not peer-reviewed, it's a report of the Institute, they say there's little or no evidence that warming was occurring or that it would occur anytime soon. And any warming that had occurred, so this is the direct response to Jim Hansen, could be accounted for by natural variability, mainly the sun. But they go on and say, but even if there were greenhouse warming in the future, it wasn't a problem because technology will fix the problem. Technology will enable us to adapt, and therefore there's no need for a treaty, and there's no need for government action at all. And it's kind of that punchline that was also a little bit of a clue for us about, well, what exactly is going on here? Because it's one thing for scientists to argue about evidence. It's one thing to argue about what you think the evidence is showing. It's another thing to take a position about whether or not we need the UN Framework Convention on Climate Change. Well, Nierenberg was then invited to the White House to brief advisors to President George H.W. Bush. And this is an important part of the story. These men have access to power because of what they did in the Cold War. Nierenberg, Seitz, Jastrow had all served on very high-level presidential advisory commissions. They knew President Bush. They knew admirals and generals. And so they have a kind of access to power that, like most of us in this room don't have, right? And that's because of what they did in the Cold War. So he gets invited to the White House, and we found various information. One cabinet affairs officer said, I was impressed by the report. Another one said, everyone has read it. Everyone takes it seriously. And this one, my favorite, from Stephen Schneider, quoted in Science magazine. John Sununu, who at the time was, he had been governor of New Hampshire, and he's White House chief of staff. Yeah, right. is holding the report up like a cross to a vampire, fending off greenhouse warming. Now, there are, of course, many reasons why a scientist or group of scientists might be skeptical of any particular scientific claim. So this is not an argument against skepticism. Healthy skepticism, of course, is part of any live science in the form we call curiosity. It drives inquiry. But these scientists weren't just being skeptical about climate change. They were also being skeptical about a whole set of issues, including nuclear winter, the ozone hole, acid rain, and the harms of tobacco. And again, so as this story was sort of building up, when we came across the tobacco stuff, we said, wait, hold on. What does tobacco have to, I mean, these at least you could claim, I mean, these guys are physicists. They're not atmospheric scientists. They're not geochemists. But still, I mean, a physicist could, know something about atmospheric physics, maybe, although these guys don't really, but they think they do. But, but the point is they're not actually skeptics at all, because a skeptic can be and wants to be persuaded by evidence. These men were not skeptics. They were merchants of doubt. They were selling doubt about a whole set of issues. So in fact, this story actually has two origins. Well, I should say three. So one origin is Tyndall. That's the origin of science. One origin is the Marshall Institute and STI. But now there's kind of a third origin, and that's in the tobacco industry. It's well known now from the work of colleagues of ours like Robert Proctor and Alan Brandt, the story of how the tobacco industry used doubt to challenge and belittle the scientific evidence of the harms of tobacco and delay tobacco control. So that's a story that's extremely well documented. For more than 30 years, actually more like 40 years, because it's even, actually 50 years because it's even continuing today, the tobacco industry staved off litigation and strong regulation by emphasizing scientific uncertainty, by fostering doubt about the scientific evidence of the harms of tobacco. An important figure in that story was Frederick Seitz. And this is another sort of fun story. So when I first came across Seitz's stuff in the tobacco, and I didn't really know that much about the history of tobacco except having read a few articles that some of my colleagues had written, I contacted Robert Proctor at Stanford, and I said, Robert, have you ever heard of a guy named Frederick Seitz? And he says, how much time do you have? And the next day I have like 55 PDFs in my mailbox of materials about Frederick Seitz. So here's a little bit about what we know about Frederick Seitz. Between 1975 and 1989, RJR Nabisco spent $45 million on a biomedical research program to support research that focused on the causes of degenerate diseases other than tobacco. So in other words, this is what we call distracting research. Don't worry about how tobacco causes cancer and lung cancer and heart disease. You worry about asbestos. Worry about the role of stress in heart disease. And it's not that this work was false, because of course asbestos does cause mesothelioma, but the whole purpose was to distract attention from the role of tobacco. So it's like the magician, waving his hand so you don't notice the rabbit that he's pulling out of his hat. Now, $45 million, that's a pretty good chunk of change even today. That was a huge amount of money in 1979. Just for comparison, the whole NSF budget in 1975, I looked this up, for ecological and evolutionary biology, $1 million. Okay? So, and this is just one program out of a host of programs that the tobacco industry was involved in. And this particular program actually was cited in the RICO prosecution by the US Department of Justice as part of the conspiracy to commit fraud against the American people. So we know that this was illegal activity. And the director of that program was Frederick Seitz. 1984, so while he's still involved in this, he becomes the founding director of the Marshall Institute. So sometimes when I give talks in public to people who don't know my work, they say, wow, this sounds a lot like what the tobacco industry did. So yeah, it's not just like what the tobacco industry did. This is what the tobacco industry did. Okay, so Seitz and his colleagues at the Marshall Institute applied the tobacco strategy to sow doubt about a host of issues, and it included global warming, acid rain, and the ozone hole. It was a whole set of issues where scientific evidence was pointing to serious environmental or public health effects. And this is the story that we outline in detail in Merchants of Doubt. But why? Why would distinguished scientists deny the reality of environmental and public health problems for which there was substantive evidence, rejecting the work of their own colleagues, even in many cases people in their own institutions? In fact, in some cases people they had hired. Bob Jastrow hired Jim Hansen at NASA. And why would a credible, reputable scientist make common cause with the tobacco industry? Well, a lot of people would assume the answer is money, that these people simply sold out. But we came to the conclusion that really money was not what this was about, at least not for these men. It's not to say that money is not important for some of the other organizations that fund climate change denial today, but at this point in history. And to get at this, I turn now to a fourth person in the story who, more than any of them, kind of articulated the ideological framework behind this. And this is the fourth physicist in the story, Fred Singer. Like the others, Singer was a Cold War scientist. He had worked on the early years of the American rocketry programs and then became the first director of the US Weather Bureau National Weather Satellite Programs. Between 1989 and 2003, Singer published at least 35 different articles, letters, and opinion pieces in popular journals challenging the scientific evidence of anthropogenic warming. He was involved in a famous, some would say infamous, campaign to claim that Roger Revelle had changed his mind about climate change just before his death, despite what all of Revelle's colleagues and students maintained was the truth. And like these other physicists that he worked with, he challenged the scientific evidence related to acid rain, stratospheric ozone depletion, and climate change. And like Seitz, he also worked with the tobacco industry, questioning the evidence of the harms of tobacco. One particular incident stands out in which he really reveals his thinking about the issues that he's addressing. And it has to do with the question of secondhand smoke. So in 1986, the Surgeon General issued a report on the health consequences of involuntary smoking, in which they reported on scientific evidence concluding that involuntary smoking, also known as passive smoking or secondhand smoke, is a cause of disease, including lung cancer in healthy non-smokers, especially children. And partly as a result of this work, and partly as a result of their own independent reviews, the EPA in 1992 declared secondhand smoke to be a Class A, or proven carcinogen. 2 years later, Fred Singer challenged this evidence in a report called EPA and the Science of Environmental Tobacco Smoke. Now, Singer had been working as a consultant to the Philip Morris Tobacco Company, and he now joined forces with a lawyer named Kent Jeffries, who was affiliated with the Cato Institute and the Competitive Enterprise Institute. So we see again the role of think tanks here in challenging scientific evidence. But the report was not published by these groups. It was published by yet a fourth organization. So we have the Marshall Institute in the background. Now we have these two institutes. It's issued by a group called the Alexis de Tocqueville Institute, who claim to promote democracy in America. Nice. But it's actually being funded by the Tobacco Institute, which is an arm, claims to be the research arm of the tobacco industry. So what we see here is the beginning of how this thing operates, right? That it's a kind of shell game. Tobacco industry gives money to the Tobacco Institute. Tobacco Institute gives money to the Alexis de Tocqueville, who published a report written by people who were being funded by the Cato Institute and the Competitive Enterprise Institute and the Marshall Institute. But then the Marshall Institute says, we don't take any money from tobacco. So what did they say? Well, the EPA, as I said, had concluded that, well, here, ETS. So this is a fun little anecdote. I'm giving too much detail. I won't finish in time, but one more, and then I'll try to move on. One of the things the tobacco industry was very skillful at was at trying to manipulate language. And whenever anybody came up with language that seemed to be damaging to their case, they would try to change the language. And we see this happening in climate change as well. So the tobacco industry did not like the phrase secondhand smoke because they reckoned that Americans didn't like secondhand things. So they decided that they would call it environmental tobacco smoke because environmental, you know, we all think the environment is a good thing, right? This was a rare tactical error on their part because if it was environmental tobacco smoke, then it invited the scrutiny of the Environmental Protection Agency. So they kind of lost that one. Anyway, EPA concluded that, and EPA loved it. They took on ETS. Yeah, of course it's environmental. So they took it on, and this was based on an independent scientific review of more than 6,000 articles published in peer-reviewed scientific and medical literature. They concluded that there were 3,000 additional adult lung cancer cases in America every year from secondhand smoke, and between 150 and 300,000 cases of bronchitis and pneumonia in infants and young children, and that it was statistically correlated with an increase in sudden infant death syndrome. And that's a finding that has been corroborated by subsequent research. So why would Singer, a physicist, and Jeffries, a lawyer, take funding from the tobacco industry to challenge an expert scientific panel of oncologists, epidemiologists, and other public health officials? Well, here's what Singer said in his own words about why he wrote this report. So this is in the introduction to the report. If we do not carefully delineate the government's role in regulating dangers, there's essentially no limit to how much government can ultimately control our lives. So an argument about personal liberty and freedom, an argument about government and governance, and a worry about loss of freedom. And this worry, this theme is one thing that you can find throughout contrarian and skeptical arguments. Indeed, on various occasions, we see Singer and his colleagues suggesting that environmentalists are really socialists with a hidden agenda to bring down free market capitalism. And some of us discussed this in the seminar earlier this afternoon, which is why I always disclaim any intention to bring down free market capitalism, much as I might actually like that. So for example, when questioning the basis for the Montreal Protocol to protect the ozone layer, Singer wrote, and then there are those with hidden agendas of their own, not just to save the environment, but to change our economic system. Some of these coercive utopians are socialists, some are technology-hating Luddites, and most have a great desire to regulate on as large a scale as possible. I love that quote because I just had this image of Roger Revelle sitting on the beach in La Jolla, just dreaming up ways to regulate as at large a scale as possible, you know? Just doesn't really make sense. And then he did the same when it came to the issue of global warming. So here's something he wrote in 1991. More dangerous are those who have a hidden political agenda, most often oriented against business, the free market, and the capitalist system. Of course, after the collapse of socialism, it is no longer fashionable to argue for state ownership of industrial concerns. The alternative is to control private firms by regulating every step of every manufacturing process. So you see this argument that regulation is actually a kind of backdoor approach to communism. And we see this throughout contrarian writings, that this is really about an attempt to undermine free market capitalism, that it's about a threat to the market, it's a threat to personal freedom, and the implication, or even in some cases the outright accusation, that environmentalists are really communists in disguise. So they refer to environmentalists as watermelons, green on the outside but red on the inside. George Will has called environmentalism a green tree with red roots. Anyone here who teaches environmental history and knows anything about John D. Rockefeller knows that that's kind of a weird claim. And Senator James Inhofe, senator from Oklahoma, who has threatened to indict climate scientists, has accused scientists of being part of the liberal conspiracy to bring down global capitalism, to which I respond that liberals should be so organized. More recently, in June 2011, when Mitt Romney was running for president, he said that he did believe that humans had contributed to climate change. Before he had a chance to change his mind, he got attacked by Newt Gingrich, who responded that the push to address climate change is just the newest excuse to take control of our lives. So this idea that it's all kind of a conspiracy, a backdoor to regulation, a backdoor to communism, a backdoor to liberal control. Now, of course, this may look like partisan politics, and some of it is, but there's an intellectual model informing this. And it helps to explain the continued Republican opposition to accepting the scientific conclusions about climate change, even in the face of frightening events like Superstorm Sandy, the recent floods in the UK, or the drought that is going on right here in California. And it's this conceptual model, what I refer to as the model of capitalism and freedom. And it was a model that was built by two key thinkers, Frederick von Hayek, who's often considered one of the founders of neoliberalism, and Milton Friedman, the American Chicago School, founder of the Chicago School of Economics. So what is the argument? Well, both Milton Friedman and Friedrich von Hayek were economists, but the argument of these books is not primarily economic. It's not primarily an argument in defense of the free market capitalism as an efficient means to deliver goods and services. It's a political argument that capitalism and freedom are linked. And if we want to preserve political freedom, we have to preserve economic freedom as well. And here's how the argument goes. The crux of it is that the free market is a form of distributed power, that various individuals making free choices every day hold power in their hands and prevent its concentration in tyrannical centralized government. Conversely, centrally planned economies entail not just the concentration of economic power, but of political power as well, because a centrally planned economy can't work unless the government has control of people's decisions about all kinds of different things. So the free market, according to this argument, is a bulwark against totalitarianism. I think I can skip that. Now, von Hayek developed this argument originally in his book Road to Freedom in 1944. I'm going to skip this detail. I think we don't need that. But it became an argument, a kind of Cold War argument in the hands of Milton Friedman after the war. So von Hayek was primarily concerned about what was going to happen to the democracies of Western Europe, in Britain and France and Germany, at the end of World War II. And he was very worried about the rise of communism, and also particularly like in Italy, where the communists had been the most important people to resist Mussolini, or in France, where the communists had played a big role in the resistance. But actually, that's not what happened after World War II. Most of the countries of Western Europe became more democratic after World War II than they had been before. But Milton Friedman picks up the argument in the United States, and he turns it into a Cold War argument against the Soviet Union, and an argument for limited government in the United States. So to return to our scientists, our physicists, for Jastrow and his colleagues, the Cold War battle to protect freedom was not just being played out in the realm of nuclear weapons and rocketry and strategic defense, but also in the realm of government intervention and regulation. And hence the origins of this story in STI. The goal of STI was the same as all Cold War US weapons and rocketry programs, to defend the free world against the threat or perceived threat of communist expansion. Jastrow and his colleagues understood their work as the technological arm of the political commitment to defense of freedom. And there are all these letters where they talk about that, where they invoke the founding fathers and preservation of liberty for future generations and all that kind of thing. Now, of course, the problem with this argument is the problem of market failure. Well, there's lots of problems with this argument, but the big, obvious, glaring one is the issue of market failure. That is to say that acid rain and ozone depletion and climate change and health damage from tobacco are all market failures. And by that I mean they're problems which industrial and commercial activity has created, but which the free market does not seem to have a solution. Failures that seem to require government intervention in the marketplace and limits on personal or at least industry freedom. So if climate change is real and threatening, then we clearly have to deal with it. But how do we do that? Well, if we think about most of the proposals that have been on the table in recent years, they all involve government interventions in the marketplace and or limits on personal freedom. So forms of taxation, regulation, international treaties, emissions trading, these are all government interventions in the marketplace. And these problems emerged scientifically just at the moment that the Reagan administration was arguing for less government and less regulation as advocated by Milton Friedman. And here we see Milton Friedman being greeted by Ronald and Nancy. In other words, these scientific and public health problems came to the fore, particularly not so much tobacco, but acid rain and the ozone hole and climate change, just as Ronald Reagan was realigning the Republican Party in the way illustrated by that graph I showed you, in ways that would inhibit its willingness to admit of market failure, insisting that the right approach to government, the right approach was not more government, but less. And so we see the Reagan administration embracing the denial of acid rain, abrogating agreements with Canada, this sort of thing. Now, in 1989, when the Berlin Wall comes down, President George H.W. Bush comes to power, and President Bush was much more open to the positive role of government. And as we've already said, he signed the UN Framework Convention on Climate Change. He also signed the Clean Air Act amendments to control acid rain through an emissions trading program. But he's also doing this right at the end of the Cold War. And this leads to a shift in some of the political discussion, even within the Republican Party and even within the Bush White House. The argument that free market capitalism has been vindicated by the collapse of the Soviet Union. And the argument that many people then begin to accept that capitalism really is freedom. And a group of people now begin to go further to argue that if capitalism is the best system, then the best form of it is its purest form, its most unregulated form. And we see Republican leaders and others, Chicago economists, to some extent, some Democratic leaders as well, Tony Blair in the United Kingdom, to some extent, Bill Clinton here in the United States, pushing increasingly for deregulation of markets. And the rise of what we could call a sort of deregulatory ideology, it's sometimes referred to as the Washington Consensus, sort of to give an impression that it's not just Republicans, but it's Democrats too, buying into this argument that we should, to the best of our abilities, release the magic of the marketplace. And this applies for not just environmental issues, but telecommunications, housing, lending, finance, right? A whole bunch of things that we've heard a lot about in the last few years. So we argue in the book that this put not only the Republican Party, but actually a good chunk of the Democratic Party as well, and a good proportion of the American people on a collision course with scientific information. So much so that just 2 years ago, congressional Republicans voted down emissions trading for greenhouse gases, even though it was actually originally their idea, because it was a market mechanism to address a market failure. So what do we do now? Having learned and detailed this kind of depressing story, I mean, for those of us who were raised to believe, grew up on the milk, the mother's milk of, the power of science and knowledge being power, where does that leave us to know that scientists could do all this good work and demonstrate beyond any reasonable doubt that tobacco causes cancer, that acid rain kills fish, that climate change is going to lead to sea level rise, it's leading to sea level rise already, and yet to see that evidence not just ignored, but worse than ignored, undermined, belittled, challenged. And also, I mean, I left out from this a whole discussion about personal attacks on scientists, a whole second talk on that. So what do we do? Well, I think it's pretty clear from our work and the work of others like Robert Proctor and Alan Brandt and Jerry Markowitz, David Rosner, I mean, various colleagues who have kind of worked now on these issues involving environmental health and safety, that climate change, like lead paint or tobacco, can't be understood simply as a scientific problem. It's a problem that is simultaneously a matter of science, politics, economics, history, culture, values, and of course also mass media and public opinion. Scientists can continue to refine their models and work out the details of ice dynamics and hurricanes, cyclogenesis, but it doesn't help us break the political, social, and cultural impasse. So Roberta and I were talking about this earlier. It's not an argument against science. It's not an argument to say that there aren't still important scientific questions to be studied. But more science doesn't break the political impasse. It doesn't even address the political impasse. It doesn't tell us what solutions we might prefer and pursue. And it certainly doesn't tell us how to get those solutions implemented. So what should we be doing as scientists, as social scientists, as humanists and artists? Well, this is obviously a really big question, so I just want to spend a few minutes now towards the end of the talk talking about that, and I hope you'll bear with me just a few more minutes, and I apologize if we cut into the reception. So I just want to say a few words to the natural scientists in the audience. One of the most important things that natural scientists need to understand is that this history is still with us. This story isn't over. In fact, it was hard to end the book because it was all still going on, and every day friends would be sending me things from the newspaper. Oh, look, here's the newest version of this, So denial continues. This is a live issue that we need to figure out how to deal with. And so one of the things I want to just spend a few minutes talking about is what not to do, okay? And sometimes it's easier to say what not to do than what to do, but in this case, there's something that's been very on my mind for the last few weeks that I'm kind of getting apoplectic about. So I'll try not to be apoplectic. I want to talk about a problem. And the problem I want to talk about is the alleged pause or hiatus in global warming. And it's so bad that I even hesitate to use these words, especially if we're like being on the internet. It's so bad that I don't want to even use the word, but I don't know how to talk about it without it. So I'm putting pause in great big scare quotes. It's the problem of responding to denialist claims in ways that give them traction and credibility. This is not a new problem, but it's happening in the moment in a particularly egregious form. So as many of you know, it's been claimed that global warming has stopped or paused, or that there's a hiatus or a cessation or a stasis. And in the last few years, there have been numerous scientific papers published in peer-reviewed journals, including Nature and Science, explaining the pause. And this is just one example, and somehow the PDF came out weird, but here you can see the introduction, the pause of global warming during 1999 to 2008. Okay, so if you read this article, you would believe there's a pause, and now this article is going to explain it to you. So as I said, this paper is a little weird because it says 99, but usually the claim is that this pause began in 1998. This is a claim that has been repeated so many times, it's all over the internet. If you type global warming pause, you'll get thousands of hits. But let's look at the data. Here's the data of what's happened to mean global temperature since 1970. So here's this is 1970. Sorry, this got cut off. But 1998, I guess, that's 2001, so about in here. Oh, no, wait, sorry. Well, I don't know. It doesn't really matter. It doesn't matter where 1998 is. The point is, there's no pause. this is very noisy data. We all know that climate is extremely variable. We all know that we have hot years and cold years. We have dry years and wet years. That's always been the case. That will still be the case in the future. It's very noisy data. So if we want to understand what's going on, the only way to understand it is to look at statistical averages over large periods of time. And this is what it looks like when you do that. This is the average mean global temperature over the last, I think it's 50 years. And there is no pause. And I'm going to say that again because the reason why I'm getting apoplectic is I have had PhD scientists tell me that there's a pause. And then I start thinking like, okay, am I going crazy or what? Fortunately, I have a few good colleagues who agree with me, and some of them are statisticians. And I'm writing a paper right now with my colleagues Stephen Lewandowski and James Risby, in which we will lay out both the statistical and the cultural argument about this. There is no pause. OK, I don't have to keep saying it. That's enough. OK. If you don't like that particular chart because you want to see more detail, you want to go back further, here's what it looks like if you go back all the way to 1880 when we first have instrumental records. And it's interesting. You can see that it's very noisy, right? But what the IPCC has said now for more than 20 years is, well, it was a lot colder in the early part of the 20th century. Then things started to warm up, and there really was a pause in the mid-century. Not much really happened through here. But then starting around 1970 or 73 or 79, somewhere in there, it begins to ramp up. And basically, this piece is the piece I showed you in the previous slide. So this is the warming. When the IPCC talks about most of the observed warming of the past 50 years, this is what they're talking about. Here's another way of looking at it. If we do decadal averages, decades are convenient. People know what decades are. Here's the 2000s. Here's the 1990s. Here's the 1980s. The 2000s are hotter than the 90s. The 90s are hotter than the 80s. The 80s are hotter than the 70s. But then, you know, it's not. So it's since the 1970s that we've seen this constant, you know, and fairly dramatic ramp up in global mean temperatures. And it's about 1 degree C overall since this is the 61 to 1990 average. Now, obviously, this shouldn't be a surprise. Based on everything we know, it shouldn't be a surprise that the world is continuing to warm up because CO2 emissions are continuing to climb. We're continuing to produce CO2 and methane. They're continuing to go up. This is 2010. So, of course, there's no reason to think that there should be any cessation of warming. Here's atmospheric CO2, the Keeling curve now being continued by Ralph Keeling. Here we are. We've hit 400 parts per million. And as we know, sea level is continuing to rise as well. So all of our other indicators are consistent with a warming trend. And I could show you data on the shrinkage of the cryosphere. I could show you data on spring thaws. I mean, there's all kinds of different indicators, all consistent with the fact that warming continues. All of the available evidence shows us that warming continues. And that makes sense because the forces that drive it remain unabated. So why would a credible scientist try to explain something that doesn't exist? I mean, a physicist wouldn't write an article explaining the ether. An astronomer would not write an article explaining epicycles and difference. And biologists don't explain miasmas anymore. And yet, we are explaining something that we know doesn't actually exist. Oh, here we go. OK, so what is this claim based on? I mean, clearly, the scientific community as a whole has not all gone completely insane, right? At least let's hope that's the case. Well, the claim is based on cherry-picking the data. And this is an old contrarian trick. In fact, my good colleague John Cook in Australia put together this, reminding us that contrarians have been claiming for years that warming has stopped. Every now and again, they take a group of data, noisy data, and they take out a piece of it, and they show us that there's no warming, right? And this is what it looks like for them, right? Well, that's true, right? You can do that if you cherry-pick the data, but the overall trend is still going up. And they've been making claims like this since the early 1990s. The latest version is this. This is what the pause claim looks like. It's based on starting in an exceptionally hot year. 1998 was an El Nino year, and at that time, it was the hottest year on record. Now it's the second hottest year on record. 2013 actually beat it. So if you cherry-pick the data of a noisy data set, and you start in a year that you know is exceptionally hot, then you can get a pause. You can claim that there's no warming since 1998, right? And that's what this claim is. There are many earlier examples of this. I think I'll skip this because time is getting short. The point is, we know that they've been doing this for a long time. Here's an example from the early 1990s, an ad campaign. If the Earth is getting warmer, why is Kentucky getting colder? Here's another way of viewing it. When you have very noisy data, you can get almost any trend you want by cherry picking the data, simply by choosing appropriate starting points. So you could do a thing where you'd say, oh, look, it's cooling, right? Now, just for a minute, I want you to imagine the opposite. Imagine an alarmist view of the same statistical trick. Look, warming has accelerated. Now, if this is obviously fallacious, and if a student did this, we'd flunk him, right? If environmentalists did this, the scientific community would be the first group to disassociate themselves. Oh, that's cherry-picking data, it's statistically bogus. And yet this is what the contrarian community has done, and the scientific community is taking it as a credible claim and explaining it. So why are scientists taking this seriously when it's obviously fallacious? Well, oh, and this is just one more thing. Just in case you're thinking that I'm just making this up and it's not really happening. So this is the IPCC, right? The authoritative body. And here's what they say about this. In addition to robust multi-decadal warming, global mean surface temperatures exhibit substantial decadal and interannual variability. OK, we knew that. Due to natural variability, trends based on short records are very sensitive to the beginning and end dates, good, and do not, in general, reflect long-term climate trends. OK, so they're pointing out an important point. It's sensitive to beginning and end dates. But then listen to this. As one example, the rate of warming over the past 15 years, 98 to 2012, and then, oh, sorry, this got cut off, but then they give the rate, which begins with a strong El Nino, is smaller than the rate calculated since 1951. But why do that? Why start in 1998? Why not just leave it at that? Therefore, why not just say, after this sentence, which is correct, say, therefore, it's not meaningful. And it's particularly not meaningful if you start in a year that you know is abnormally hot, or a year you know is abnormally cold, right? And yet, instead, they buy into this, and they give us the calculation based on starting in 1998. OK, so I'm going to skip this. It's obviously clear. OK, so I've talked to a few of my scientific colleagues about this. I said, why are you doing this? You know this is statistically fallacious. And they agree. They know it is. But they say, well, we feel we need to respond. And my argument is, well, maybe. Sometimes the scientific community does need to respond to fallacious claims. But by responding in this way, you reinforce the claim. Or to use Dawkins' terminology, you reinforce the meme, right? If you explain the pause, it implies that there is a pause. If you engage in debate, you help to create and sustain that debate. And this is something, of course, that biologists, evolutionary biologists, know only too well. So if you can't see the caption, it says, I think it's important for them to hear both sides of the debate. And there's the devil in church. OK, so biologists learned the hard way that debating creationists doesn't really work. Climate scientists need to do something similar. They need to understand the political and social context in which they're being challenged and frame the responses accordingly, and not in a way that seems to infer the reality of a fallacious claim. I'm not saying that's easy to do. I think it's quite challenging. But this needs to be something that the scientific community is aware of. Experience suggests that the scientific community does need to respond to anti-scientific claims. But experience also shows that it's almost always a mistake to respond on your opponent's terms, especially when those terms reinforce the false claims. So I think the climate scientists should sit down with their evolutionary biology colleagues and talk about this, because evolutionary biology has gone through this issue and learned a few things. OK, quickly, just a couple more things, not to neglect social science. It's obvious there's a huge number of social science issues here. I think any social scientist in the audience can immediately see all kinds of things you could work on. So I'm not going to belabor that point. But obviously, rational actor theory doesn't explain any of this. A lot of questions in economics that have begun to be worked on, but lots more work to do. Interesting questions about technology, scaling, technology transfer, whether technology does the things it promises to do. All kinds of issues about governance, so I'll just leave those for people to think about or speed read. Geoengineering, a million social, cultural, legal, and governance issues around geoengineering. And maybe the most important question of all for social scientists and humanists to think about. What should be the role of experts in a democratic and majoritarian culture? One of the questions that comes up a lot for me, that came up a lot for me and Eric when we were writing our book is, so are we saying that we should just trust the experts, that we have to all just kind of lay down and do what climate scientists tell us? Well, obviously not. Obviously in a democracy, that's not a reasonable suggestion. But what is the right way to think about the role of expertise? What is the right way to think about scientific claims that we as lay people can't really judge? And I think that's a big open question that we've only just begun to scratch the surface of. And then I just want to spend 1 minute now talking to the artists and the humanists in this room. So in general, humanists have not really taken up climate change as a substantive issue for humanistic analysis. And I think that there are lots and lots of opportunities there. I think there are extremely rich questions in history and philosophy and literature that can be addressed about climate change. But to me, personally, the most important one to address, the one that I have really felt when I've lectured in public, is the question of articulating the meaning of climate change, by which I mean a lot of things, actually, because there are many meanings of climate change. But the feeling I get when I speak in public is that the general public, even people who accept the reality of climate change, even people who agree we need to do something about it, they still don't really have a clear idea, or what I would say, a clear or strong feeling about why climate change really matters. That is to say, not just altruistically that we should care about people in Bangladesh, or altruistically that we should care about polar bears, but why it matters to us. And I've had lots of people, including my own colleagues, educated people, saying things like, sorry, but I have trouble getting excited about polar bears. There's this feeling for a lot of people that climate change really isn't about us, that it's somehow about other people, and that being concerned about it is just a form of liberal altruism. And for a lot of people, that doesn't really move the needle. So I think we need to explain it. And that means we need to think about it. We need to think through more clearly and more effectively why climate change really matters. Because you can't ask people to consider a major restructure of the entire energy infrastructure, or maybe even the entire structure of capitalism, with all the costs and disruptions that that would entail without a compelling justification. And I'm not sympathetic to what Bill Nierenberg and his colleagues did. I'm not sympathetic to contrarians who cherry-pick data and do things that you should flunk a freshman in a statistics class for doing. But I am sympathetic to this argument, that we need to understand why this really matters if we're going to be asked to restructure our entire economic system. I've just spent $20,000 on a PV system. I'm happy to be in a position to be able to do that. But if you're going to start asking people to shell up significant upfront investments of time, of money, of technical resources, of regulatory expertise, to work on new policies, new ways of thinking, to change their patterns of consumption, these are really big asks, right? To put it in that philanthropic language. So it's just like if you go to a philanthropist and say, I want money to support my university, you've got to have a compelling justification, and we need to do that here, and I don't think we've done it. And the scientific community can't, because it's not their job. It's not what they do. It's our job. Meaning is not the domain of science, and it's not, for the most part, conveyed in charts and graphs, and it's not, in general, communicated in numbers. In fact, as far as I can tell, it can't be quantified. But it can be conveyed in a picture like this, and maybe in a story like this. And so this is why my next book is a venture into a wholly different genre, the genre of fiction, and I hope that when this book comes out later this year that many of you will read it. Thank you very much.
That's the other part of it, and a lot of those effects are decades away or centuries. So there's the psychological problem, the long-term threat that's hard for people to wrap their brains around.
Yeah, I think that's true, but I also think that it's not as difficult a problem as sometimes it might seem. You know, it's like people say the end of the year, the world is always 30 years away, or peak oil is always 30 years away. I mean, one thing that's happened in the climate science community, and I've noticed this even in the 10 years that I've been working on this issue, climate scientists are always talking in the future tense, and they're always pushing back their predictions, you know, into the future. But the fact is there are a lot of changes that are already happening now, some of which, as I already pointed out, were predicted 30 years ago. So I think that we could do a lot more to talk about the changes that are already underway and the costs, both the cultural costs, the financial costs, the psychological costs that are associated with that. So if we think about the problem of hurricane intensification, you know, you immediately get into this whole discussion of how no one hurricane, blah, blah, blah. Right, fair enough. Okay, let's not talk about one hurricane. Let's talk about the entire 2005 hurricane season. Or let's talk about the decade, the last decade of hurricanes. And let's add up all of the damage. And I don't just mean the monetary damage, right? Because then you get into arguments with Roger Pilkey about more people living on the coast. The damage of hurricanes isn't just monetary. It's cultural, it's psychological. People who live through natural disasters like that have their basic sense of physical safety and security ripped out from under them. And if you talk to people who study like hurricane survivors, it's like it's post-traumatic stress disorder. These are like people who have suffered, you know, horrible traumas, and they live with that for the rest of life. So there are enormous costs associated with the increase in extreme weather events, and we could be talking about that. And again, I'm not sure that climate scientists, the people who analyze the hurricanes or build the models, may not be the best people to talk about that. They may need to work in conjunction with social scientists who have studied the damage to communities. But I think that kind of conversation can be very helpful. And the same with droughts. You know, look at the historic drought in Texas. I mean, droughts are incredibly costly, and particularly agricultural communities. Agriculturalists know what it means to live through a devastating drought, and they know what it can do to communities, and they know how horrible it is to be in the situation of, say, having to kill your livestock, you know, before they die of dehydration. So these are things that we can talk about. And we also have historic models. This is where I think historians could do a lot more. You know, the Dust Bowl was one of the signal events in American history, and it changed America forever, right? California is what it is today in part because of the Dust Bowl, right? So, and the Dust Bowl, we know, was not simply a natural phenomenon. It was a combination of natural forces together with human practices. And in that sense, it's quite similar to climate change. So we could talk about that, and we could talk about what we know, and we could say, this is what we're talking about. We're talking about more of this kind of thing. And it's true. I can't tell you for sure if this will happen next year, or 5 years from now, or 10 years from now. But I can tell you for sure that your children will be living in a different world. And it's a world that's going to have more of this kind of damaging thing in it.
What not to do for natural scientists. And you're saying, don't answer on their terms. So then how do you flip that to what the way to do it right? And you had images from skepticalscience.org. Are they doing it right? And what are they doing that's getting away from answering it on the other's terms?
Yeah, that's a great question. So if you don't know Skeptical Science, please go to their website. You know, they're doing a great job, in my opinion. And one of the really interesting things about skeptical science is that John Cook, who founded it, isn't a scientist. So maybe that's telling us something. You know, I think scientists have certain cultural expectations about what constitutes a good argument, how a scientific argument should be framed, the error bars, the caveats, the being clean about what you don't know. That's all a really important part of scientific culture. And I'm not arguing that that needs to change inside science. I think that within science, that kind of, you know, meticulous articulation of the limits of knowledge is really important. But when you speak to people outside the scientific community, it's different. And that's, I think, one of the things that we have to get our head around, that some of us talked about this earlier today. A lot of scientists will say, well, you know, there is no other way to talk about it. I mean, I've had scientists say that, or I don't know of any other way, or I don't know how to talk about this in any other way. And I don't think that's true. I think actually a lot of us know a lot more about communication than we give ourselves credit for. But the problem is we don't trust our instincts. So the question I posed in this particular one, this was a median NCAR, so a group of very distinguished, famous, wonderful climate scientists who had come to a workshop on climate communications. That means they were self-selected as people who wanted to do a better job speaking outside of the scientific community. And one of them said, well, I don't know how to talk about my science without differential equations. And so I said, okay, I want to ask a question. And I can do it here, too. This is a bit of a younger crowd. This was scientists who were mostly in their 40s and 50s and older. But I said, how many of you have children? Raise your hands. So, you know, like 2/3 of the room raised their hands. And then I said, okay, if your hand is up, keep your hand up if you sometimes talk to your children about your work. Everybody leaves their hands up, right? We all talk to, if we have children, we all talk to our children sometimes about what we do for a living. And then I said, how many of you talk to your children about your work in exactly the same way you talk to your colleagues, right? And then, okay, they got it. You do know how to talk about your work in different ways. You just actually don't realize that you do. So I think that, you know, a certain amount of trust in your instincts, common sense, thinking about how you already talk to your children, your partner, your mother, your neighbors, your hairdresser. I mean, I use what I call the hairdresser test. Whenever I'm trying to work out something complicated that I want to explain in plain language, I imagine myself explaining it to my hairdresser, who's an intelligent person but not scientifically educated, right? And that's, you know, like really great. So everybody's got someone in their life. I mean, most of the women probably do have a hairdresser, but if you don't have a hairdresser, you have a dentist, or you have, you know, there's someone in your life who fits the hairdresser niche, right? So, what's that? No, you don't have a dentist? People don't. Okay, guys, go to the dentist. Okay. But, you know, your mother, I mean, every graduate student has had the experience, you know, I mean, I hope your mothers are all still alive, but, you know, most of us have had the experience of trying to explain to our mothers what our PhD is about. Not always easy, right? But we do it. We make that effort, right? So we do have experiences that we can draw on.
I love your explanation for why people are ignoring the evidence. And I've always wondered how much the fact that we often get conflicting information in the news over short periods of time. Eggs are good for you, eggs are bad for you. Red meat is good for you, red meat is bad for you. How much that has led to an overall skepticism of scientific results, especially, I know, particularly with respect to human health, because that's what people really tune into. How should they change their lives? And then it's constantly flip-flopping.
Yeah, I think that's a really big issue. And I don't know if anybody's looked at that specifically. Max Boykoff has done some nice work on media coverage of climate change. But I've certainly had many people say that to me personally. Well, scientists are always changing their mind. And then I say, well, what are you thinking? Like, what's an example? And they'll say, like, oat bran. You know? So there is definitely the media coverage of short-term, faddish conclusions in medicine and public health, I think, is a problem. And then there's kind of a conflation of medicine and nutrition with, you know, what we would call science, right? So that's tricky. I don't want to offend any of the medical people in the community. But, you know, clearly medicine and nutrition, you know, have some challenges that are a little bit different than climate modeling, which is not to say that climate modeling doesn't have challenges too, but you know what I mean? So I do think that is a contributory factor. And I don't know, I haven't really thought through, you know, what the solution is. But some of the people who study science in the media, like there's the Pew Center for Journalism, they've done some stuff on science journalism. So that might be a place to look for some thoughts about that.
So I think that there's a tactic that you have already achieved and that climate scientists are achieving very well. And I've used this, and I discovered that I was using this with my friends who retired engineers, all of them Republicans. And it works, and I'm very, very careful with what I say. They were going on about something that they'd heard from the talking head or something, and I stopped and I said, well, those are the merchants of doubt. And the whole group stopped and they said, what do you mean? And I went right down your list. Tobacco, and what they did with the ozone hole, etc. And it actually changed the conversation. Another one that really works, I've got a list of them. Do you have time for another talk? Another one, the title Jim Hanson's work. What is it, Storms of my, for my grandchildren. And that's a stopper. Another one that has worked, and I've used it on my buddies, and they actually have become interested in this. And I say, they will almost all, you can't explain weather. You can't explain why we're having a drought. And the metaphor that stops that cold is rolling the loaded dice.
Yeah.
And there's a nice list of these that have come out of climate science, And I think that it's a strategy that can work in this arena that you're describing, this echo chamber that's coming from right-wing funding of the media and those kinds of cable news outlets. So there are tactics and strategies that work, and they work in very subtle ways.
Yeah.
They work in gentle, quiet ways. And I know people who know me say it's very strange for him to say that.
I know what you mean. When I'm in smaller groups, I'm quieter. No, I think that's a great suggestion, and that leads me into another story, though, that's relevant to that. So I think that's exactly right. And the use of a metaphor like rolling loaded dice is very helpful because everybody knows what that means, right? But so I was in a group of scientists about 1.5 years ago in which this issue came up about the loaded dice, because I guess Al Gore had used that metaphor. So the scientists started having a fight about the metaphor, and they started arguing about whether it should be loaded dice or no, it's like you're painting an extra dot on the dice because now you're getting hurricanes that you would never have got before. And they're having this really big argument, and they're going on for like 10 minutes. And finally I said, guys, it's a metaphor, right? You know, so, but this is the problem, right? Metaphors are all about slippage, and you have to allow that slippage. That's the whole power of the metaphor, is the slippage. So scientists have to understand that the slippage is good and not argue about, you know, is it painting the dice or rolling the dice? Yeah.
Okay, let's take one more last question, and then let's go here and then.
Thank you. Really, we're talking about a language war and marketing and money that supports that. And I was hoping you were going to give us a list of sound bites that we could all go home with. And which strikes me that, you know, our country has hundreds of thousands of science majors that are graduating every year. You'd think that would be a pretty good inoculation to trust science. And this is actually, it's great to see Dr. Dexter here. How can we, as a higher education, inoculate or arm our science graduates to go home and into the shopping malls, into their houses of worship, to have the sound bites that are, in the words of Stephen Schneider, a credible sound bite that has the momentum of merchants of doubt, and instead of saying a free market, how about a distorted market?
Yeah.
To change, and then so who is providing those credible sound bites? Is there a think tank for science to provide those catchy phrases that we should arm ourselves with? Because scientists, we acknowledge uncertainty when actually we should be using likelihood. It's really, really likely that you wouldn't set up a picnic on the train tracks because it's uncertain that a train might come.
Right, well that's good. I like that. That's a good one. I like that a lot. That's great. Can I steal that? No, that's great. So that's QED, right? So actually we do have our own sound bites. So if we think about it, we actually have our metaphors, our examples. You wouldn't set up a picnic on train tracks. Well, you might in New England where there hasn't been a train in 100 years, but you know. Right, so I think that's a really good example. The other thing you could do is skepticalscience.com does have great short answers. They have a really nice thing with like 10 common contrarian talking points and what the response is. And they do a very nice job of giving you both the short answer version, there is no pause, it's cherry picking. And then they also give you longer explanations if you want to get a little deeper into the science. So, you know, why is 1998 and why does the El Nino make it particularly hot? So I really recommend that site to anybody who's interested. And John Cook's a friend, so I'll even go so far as to say donate $10 to support the site. But I do just want to say one other thing about something you said. I don't think the message we want to send is trust the science. I think that's a little too brutal and oversimplified because it isn't, I mean, on some level there's a component of trust, and this is a complicated issue we could spend a lot of time talking about. And it's something that we were really grappling with at the end of Merchants of Doubt, how to talk about trust in a way that didn't just say like we were just handing over democracy to the scientists, because we know that that's not an adequate solution, and we know there are certainly, well look, I mean, Bill Nierenberg and Fred Seitz presented themselves as experts and presented themselves as trustworthy. So it gets us into questions about what is the basis for asking for societal trust. And I do think the scientific community hasn't really talked about that quite enough. I mean, on what basis are we asking people to believe that the things that we've done, and I say we, collectively, because I also mean social scientists and academics and scholars of all types, what is the basis for asking for society to believe the things, to accept the things that we have to say?
Evidence?
And yeah, right. I mean, well, but how do we use evidence? How do we judge evidence, right? So at the risk of sounding like I'm just, pleading for my own discipline, but I think this is important. I don't think that we, as a community, collectively, have actually done a really good job on that. And I think that for a lot of people, they hear scientists say, eat oat bran, don't eat oat bran. They hear some other person on television say, oh, it's all bunk. They just want money for their research. And the fact is, we do want money for our research, right? So how do we respond to that? And so I just think that's a really open question. And I think it's one that, it would be great to have more of a conversation around that. And also around scientific institutions, because one thing that evidence definitely shows, if you ask the American people to name a scientist, most Americans cannot name one living scientist. They'll tell you, they'll say Einstein, or they'll say, what's that?
They say Bill Gates.
Well, is that right? They say Bill Gates. Well, there you go, QED. So, and there are some reasons why that's true, but it's also because the reality is that modern science isn't really done by individuals. It's done by groups. And Americans have a kind of cultural predisposition to be suspicious of groups and to glorify rugged individualism. So that's an issue too, and so that's another thing that I think, so what does it mean? Most Americans don't know what the National Academy of Sciences is. They certainly don't know what the NRC is. If they do, they think it's the Nuclear Regulatory Commission, but they probably don't even know that, right? So if you say, well, the NRC, issued a report, that doesn't mean anything to most Americans. So that means we haven't done much of a job of actually explaining what it is we do.